Hey there, Seahawks, it's Miss Adams, and in this video, we're going to learn about sampling distributions of sample proportions. All right, a sampling distribution of sample proportions is also known as a binomial sampling distribution, since the proportions we can use come from Bernoulli trials. So remember Bernoulli trials is when you have only a success or a failure, you have a set number of trials, your probability stays constant, those things. The mean and standard deviation of a binomial random variable, this is what you learned in previous units. For a binomial random variable, we find the mean and the standard deviation using the following formulas. So the mean of the variable from your sample is n times p, and the standard deviation is the square root of n times p times 1 minus p. All right. Using proportions in a sampling distribution, p hat is the sample proportion of success. Okay, so the number of successes out of the total number of things you've collected. The mean of the sampling distribution is mu of p hat is equal to your mean from your sample divided by n. Okay, well, your mean from your sample was n times p divided by n, the n's cancel, so it's just equal to your proportion, like your p-value, whatever the population probability of success is. We set the mean of our sampling distribution to that. The standard deviation is the standard deviation from your sample divided by n. Well, the standard deviation from your sample was from the square root of n times p times 1 minus p over n. Okay, when I want to get all of that together under the square root, I would have to square the bottom piece and then get rid of one of the n's from the bottom and one n from the top, which gives me the square root of p times 1 minus p over n. All right, so really I'm just focused on them in orange. I just kind of wanted to show you how they came to be those formulas in the pink part. But you'll want just to remember them, how they're written in orange. All right, examples. In an upcoming election between candidate A and candidate B, 64% of the voters prefer candidate A. Suppose we were going to take a random sample of 150 voters and calculate the proportion of the sample that prefer candidate A. What is the expected number of people in the sample that would prefer candidate A? Well, n times p would be 150 times 0.64, which is 96. So we would expect 96 out of the 150 people to prefer candidate A. Find the mean and standard deviation of the sampling distribution. All right, so this mean is equal to p, my population parameter, which is 0.64 or 64%. The standard deviation of p hat is equal to the square root of p times 1 minus p over n. So 0.64 times 1 minus 0.64, which gives me 0.36, over 150, which works out to be 0.0392. All right, go Seahawks.